So in this video, we'll be talking about standard form. So unlike vertex form where you have something in parentheses to be able to tell which way you shift, up and down or right and left, standard form doesn't allow you to do that. Instead, there are different ways to finding the vertex, and it's using this formula here that I will write out for you guys. So the formula to finding the vertex comes in pieces. So the vertex has an x and a y value. To find the x, you need to grab the b value, which is the number or the coefficient in front of x to the first power. And you have to divide it by 2 over a, which a is the number in front of the x squared. So let me just explain the difference between standard form and vertex form. Obviously, you can see that standard form doesn't have parentheses, but this is still a quadratic because this highest power here is x squared. So oftentimes you'll see most quadratics written in this format. And it just means that they've actually taken the parentheses. So if you take a look at one of these problems here, in order for this to be in parentheses, you have to be able to keep it as a factor, right? But standard form, what it does is it distributes the 2 out and actually squares the factor and then combines all the like terms together. So that's how they get into standard form. So in this case here, A, B, and C are all coefficients or constants. And C is particularly special. So the last number that's by itself is your y-intercept, which is super nice because now finding the y-intercept is so much easier in standard form, because if you look at the equation and figure out what's the n number or the number that's by itself without an x, that's your y-intercept. The only difference is that the x for the vertex is a little bit harder to find because you have to use a formula, but it's really not that difficult, and we'll learn how to practice this together. So this here is a very important formula to know to find the vertex. To find the y, once you have x, it's pretty easy to find y. All you have to do is plug in your x into the equation and you'll be able to find y easily. So we'll practice this together. So in this problem here, we have our standard form equation. And what I like to do is start by understanding what is the numbers in front of my x's that I have. So I have 1 in front of x squared, 2 in front of x, and a -3. So this is going to be my A, B, and C. Those coefficients will be the numbers that I need to plug in to find my vertex. Now, like I said before, the nice part here is I already know my y-intercept. It's at -3. So if I were to graph this on the y-axis here, -3 is right here on the y-axis. And so I need to write that as a coordinate, so that would be 0, -3 for my y-intercept. Now for my vertex, I still need to find. And I'm going to start by finding my x value for my vertex using this formula. So to the side here, I have x equals -b over 2a. And my b value here is 2. So this is going to be a -2 on top. And then 2 times my a is a 1. So I'm going to plug in 1. So if I put this and multiply the bottom, that's going to give me 2. -2 divided by 2 is -1. So I can see my x value here is -1. To get my y value, I need to plug in this x into the equation and find my y. So to work this out, I would get +1 if I square the -1. -1 times 2 is -2. If I take -1 and subtract it by 2, I get -1 minus 3, which is -4. So it looks like my y value here is -4. So when you're subtracting, always go from left to right, just like how you would read. Subtract the first 2 and then combine what's next. All right, so once we get our vertex, let's go ahead and plot it. And so our vertex is at -1 down 4, which would be right here. Now keep in mind, it might help to make sure when you plot the vertex that you put a little V there. The reason why I say this is because sometimes my students forget that this is the vertex, and the vertex is the middle of the parabola. And if they remember that, they remember to connect the dots where they use this as the middle piece and they connect it with the y-intercept and make their U. If they mistake the y-intercept as their vertex, they might want to connect the dots and then it'd be pointing downwards instead. So remember that this part was the vertex that we found, so we're just going to connect the dots. And it looks like our other piece would be, if this is a vertex, then if I were to reflect the y-axis, well, here's my line of symmetry. So the line of symmetry always goes through the x-axis, in this case at -1. This is about 1 unit away, so I have to go 1 unit away to the left this time and plot. And then connect my dots. So from here, I have my line of symmetry at -1. Oops, that's a highlighter. I can see that this vertex is a minimum because it's the lowest point on this parabola. My domain is all real numbers because the quadratics always have all real numbers. It's pointing left and right with an arrow, so we're going to -infinity to +infinity. The range here, the lowest y values at -4, and the highest is going to be infinity. So this is from -4 to infinity for the range. As far for solutions, let's see. I see 2 solutions here. There's one right here and one right here. So I'm looking on the x-axis to see where it crosses the x-axis. And it's kind of hard, but I think I'll just estimate it to be -2.5 and 0.5 on the other side. So -2.5 and 0.5, about a half, because it's in between 0 and 1. This one's kind of in between -2 and -3. So as long as your numbers are fairly close to my numbers, you should be fine. It's just based off your drawing. All right, let's try one more of these problems. So this one here, again, it's in standard form where you can kind of see your A, B, and C. So this number here in front of the x squared is like a -1. That's my A. My B is a -4, and my C is also a -4. And again, we're in standard form, so I already can see what my y-intercept is, which is the C value. So this is at -4 on the y-axis. So if I go down to the y-axis and plot, then my y-intercept is at 0, -4. From here, I need to find my vertex because I need more points on the graph to make my parabola. And I need that formula for x to find the vertex, which is -b over 2a. My b here is a -4. So don't forget the negative that the formula comes up with. And then the b is also a -4. So there's 2 negatives on top. And the bottom here is being plugged in an a, which is -1. So a lot of negatives. So the top here has 2 negatives, so that becomes a +4, and the bottom is a -2 if I multiply the 2 and the -1. From there, if I divide, 4 divided by -2 is -2. And so I know that my x value for the vertex is a -2. For the y value, I have to go ahead and plug this number in for x and then find y. So if I were to use order of operation, -2 squared gives me 4. And so I bring down the +4, but there is a negative in front, so I need to bring that down. 2 negatives on the 4 and the 2 make it a +8. 4 times 2 is 8, but it's a positive because 2 negatives. And a -4 is brought down. So -4 plus 8 is +4. Bring down the other 4. Well, this gives me 0. 4 minus 4 is 0. So my vertex is at -2, 0. So -2 is over here, and 0 would just be on the x-axis, so right here. So this is my vertex. So I'm going to put a little V there to remind myself. If this is the middle, then that means I need to connect the dots to this point here. So this one curves down. And probably the reason why is that there's a negative sign in front of the x squared. If there's ever a negative sign in front, it's probably going to be pointing down. If there's a positive sign, it's probably going to be pointing up. And this specifically if you have an x squared. So we can kind of see that our axis of symmetry, or how many units it's away from this y-intercept from the vertex, is about 2 units away. So this point is about 2 units away from the vertex. What I can do is use the y-intercept to reflect across the axis of symmetry to make my third point. So my axis of symmetry is at -2. So if that's 2 units away, I can go 2 units to the left and plot to reflect. So the axis of symmetry is really handy because it helps you reflect and get your third point usually. So I have my picture now, and I can see that this vertex is actually a maximum because it's the highest point. So this is a max. My domain is all real numbers. Notice that it still points to the left and to the right with an arrow. So even though they're pointing down this time, they're still pointing left and right. So this is going to be all real numbers. The range has changed though. Notice that the highest value here is at this maximum, which is y equals 0. So that's the highest point. The lowest point, notice how it's pointing down. So if it's pointing down, it's going to -infinity for y. So this is going from -infinity to 0. The solution here, if we look at our x-axis, it only hits the x-axis at one place, which is right there at x equals -2. So we have one real solution at x equals -2. And that is it for this problem. In the next video, we'll try out some of the practice problems that are on the third page. All right, that's it.